Hello students, welcome to Fun Scholar. So today we are going to discuss the topic of rational numbers. This chapter is meant for class 7 CBSE board students, but as you know that rational number chapter is omnipresent in all the classes, whether it's CBSE or it's ICSE. So let's start. So first, before starting the chapter rational numbers, we will discuss a little about what are the numbers actually. Okay, so first of all, 1, 2, 3, 4, these all are the numbers. Okay, 0, 1, 2, 3, 4, these are also the example of numbers, and these are also the numbers like 2 by 3, 5 by 8, 8 by 5, 7 by 9. I can also include minus 5 by 6, minus 7 by 8. These are also the numbers. Yes, and they will be called as the rational numbers. Okay, so this chapter we will be discussing the chapter, the numbers which are rational numbers. Okay, so let's start. So first, where do we find rational numbers? Like half of teaspoon, like half teaspoon, 3/4 cup of flour. These all are the example of rational number which can be found in nature or which we can find naturally. Okay, so we all know that these are the fractions, 1 by 2, 3 by 4, 5 by 6, but they are rational numbers as well. But what is the difference between rational numbers and fraction? We will be discussing this in the upcoming slides. Okay, so let's go next. So where do we find rational numbers? 3/4 meter length of wood. You can see that in this diagram they have described how can we measure 3/4 meter of a wood. Okay, just like this is a broken scale, but if you break the scale from 1 meter, you can have a 3/4 meter of this scale, which will be looking exactly like this or near about like this. Okay, so if this one scale, if one scale measures like this, and if we cut it down into 4 parts, like one part is this, another is this, another is this, and another is this. Okay, and if we take 3 of them, so we will be getting the 3/4 meter of the whole scale. Okay, and that will measure these equal distance like this. Okay, so it's just the explanation that how can we measure 3/4 meter. Okay, and we will be going next and learn by the video that what are the rational numbers. So let's watch the video. So here's the video, and we have learned that what are the rational numbers exactly is. Just like this one is a number line where 0 is in the middle, and after 0 it will be all the positive integers, and before 0 it all are the negative integers. Okay, and after that, if we want to represent or plot fractions between the number line, so what we have to do, we have to break it down by the denominators and place the fraction there having its numerators. Okay, and the same goes for the negative fractions as well, though I know that negative fractions doesn't exist in the mathematical dictionary, but they are the rational numbers itself, and that's why we can also represent these rational numbers as well. Okay, and after that we will be having the like a set of rational numbers in the number line itself. Okay, so let's learn further from it, from the slides. So what are the rational numbers? We already have learned. If a and b are two integers, then each of a plus b, a minus b and a into b is also an integer. Okay, however, it is not necessary that a by b or b by a is also an integer. Okay, so if you want to verify this, just take a as 2 and b as minus 3. Okay, so a is an integer, that is 2, and minus 3 is a negative integers, and they have talked about all the two integers, be it positive or negative. So a plus b will be minus 6, so a plus b will be minus 1, a minus b will be 5, a into b will be minus 6. So these all will be verified. But for this case, a by b or a divided by b will be 2 by 3 minus or 2 by minus 3, whatever. But if we take the example of a as 1 and b as 0, 0 is also an integer. So this will also be verified for a plus b, because a plus b will be 1, a minus b will be also 1, and a into b will be 0. But when we will come to do the division, it will be 1 by 0, which is not possible or not defined. Okay, so that's why we can say that a by b or a division b or b by or b division a is, we can't say it exactly that it will be an integer as well. Okay, so come to the definition of a rational number. If p and q are two co-prime integers and q is not equals to 0, then the number pq will be called as a rational number. P and q are co-primes. That means that p and q do not have any common factor other than 1. Okay, so talking about the co-prime, why do we need co-prime numbers to represent or to express the rational numbers? So if I write 2 by 6, this is, you can call that this is a rational numbers. But if I tell that yes, 2 by 6 is a rational number, but it has another expression which will be 1 by 3. So this will be the final representation of a rational number by cancelling it out. Okay, so 2 by 6 are not co-prime numbers, but 1 and 3, 2 and 6 are not co-prime numbers, but 1 and 3 are the co-prime numbers. So it is the exact expression or exact representation or the rightful representation of a rational number. Okay, so let's go next. So I hope you guys have already understand the definition which I have been trying to tell. So now let's learn rational numbers in standard form. Yes, we already discussed about this a little bit, that what is the standard form. 2 by 6 is a rational number obviously, but that's not in a standard form. So a rational number m by n is in standard form if n is positive and m and n have only 1 as their common factor. Rational number 3 by 4 is in standard form as 4 is positive and both 3 and 4 have only 1 as their common factor, or 3 and 4 are the co-prime numbers. So these all are the examples of the negative rational numbers. Okay, so talking about this, if we go by another example, if I take 10 and 12, this is an example of rational number, but this is not the standard form of a rational number. If I divide this by 2, it will be 5 by 6, and 5 and 6 both are the co-prime numbers and they don't have any other common factor between them rather than 1. Okay, so this is done. The next, write down a rational number whose numerator is the largest number of 2 digits and denominator is the smallest number of 4 digits. Okay, so let's write it down. So it will be whose numerator is the largest number of 2 digits, that is 99, and denominator is the smallest number of 4 digits, that is 1000, and they don't have any common factor in between them, so these two numbers won't get cancelled out. So this will be the final answer. Okay, now go to the next. Write the numerator of each of the following rational numbers. So first numerator will be 125 minus 125. The next one is 37. The third one will be minus 85. The fourth one will be 2 itself because it has an invisible 1 beneath it as a denominator. So 1 will be the denominator. And for the number 5, it will be 0 itself because it also has an invisible denominator as 1. Okay, so these all are the examples of the numerator they have asked us for. So write the denominator of each of the following rational numbers. The next one is same, but it is the denominators. Okay, so first one is minus 15, second one will be 29, third one will be 4, fourth one we don't have currently, but we have an invisible one, so that will be 1, and that same goes for the number 5 as well. It will also be the number 1 as the denominator. Okay, so the next one, yes, they have already done it, all of them like this. Next, here we have to find x such that we get the value of x. So let's do this for number 1. So what we can do, we can multiply diagonally to find the x. So the first one will be minus 2x equals to 18. Okay, so then the x will be minus 9. So if 1 is minus 9, so it will be 6 by minus 9, and if we cancel it out, it will be 2 by 3. Okay, done. The next one can be done similarly. It will be minus 4x equals to 56. So x equal to, it will be minus 14. Done. The third one is similarly like this. It will be, we can also cancel it out by writing this as 5. So x equals to, it will be minus 15. Okay, the fourth one is x equals to minus 48 by 6. It will be minus 8. The next one, or this one, it will be x equals to 12. If we take x here and take 3 here, we can divide 36 by 3 to have the answer as 12. The last one, you have to do it like this, minus 27 equals to 9. If we take x here from here it will be x, and taking 9 from here, so it will be minus 27 by 9. We can easily flip this and take the and write the answer as minus 3. Okay. Yes, all the solutions are here like this. Now we will learn that how can we represent rational numbers in the number line. Okay, so represent rational numbers, this all of this on the same number line. Okay, and currently they have already represented it, and how can we so first thing you have to point out the rational numbers here, and then you have to tell me that how they represented all of this in the same number line. So first of all, for minus 3 by 2, the minus 3 by 2 will lie between minus 1 to minus 2. So it's lying here and it has 2 divisions, so it will be minus 3 by 2. And the same goes for minus 5 by 2 as well, as we know that 5 by 2 means around 2.5, or not around exactly, it is 2.5. So 2.5 lies between minus 2, between 2 to 3. The same goes for minus 2.5 as well, it will lie between minus 2 to minus 3. So it will be lying here, that is minus 5 by 2. The same goes for 1 by 2 as well. 1 by 2 means half, we already know that, and half lies between 0 to 1, so 1 by 2 will be lying here. And 3 by 2 means 1.5, that lies between 1 to 2, so 1 and half or 3 by 2 will be lying here. And 5 by 2 means 2.5, it will be lying between 2 to 3. Okay, so you guys can plot the numbers or rational numbers just having the decimal numbers as well. Okay, in the number line row now obtained, P represent, yes, these are the representation of the number line. So this is another process by which you can plot the number lines, just getting the decimals as well. Okay, so the next one, every positive rational number is greater than 0 and is greater than every negative number. Obviously, every negative rational number is less than 0 and is less than every positive number, obviously, and 0 is greater than every negative number and is smaller than every positive number. So the first one, they are having examples that every positive rational will be greater than 0. Obviously, the positive number starts from 1 and which is bigger than 0, so all the numbers after 1 will be bigger than 0. So, and is greater than every negative numbers. Obviously, that minus 8 will be less than of plus 8, or minus 8 will be less than of plus 1 or 1. And the same example goes for everyone, when we already know that. So let's go next, that is compare. Okay, so it has a sum, a little sum, compare 5 by 7 and minus 3 by 5. So from this we can tell that minus 3 by 5 will always be smaller than 5 by 7, because 5 by 7 is a positive rational number. Okay, yes, and they have already described that why having it's like that. So 5 by 7 will be greater than minus 3 by 5. Compare 3 by 5 and 5 by 7. Yes, for this comparison we have two positive numbers, that is 3 by 5 and 5 by 7. Okay, so if you want to compare these two, there are so many processes by which you can compare this. The first one, that is decimal process. So by the decimal process, 3 by 5 values around 0.6 and 5 by 7 values around 0.5. 7.1 something. So from these two we can tell that 5 by 7 will be greater than 3 by 5. So this is one process. So this I am telling it as the decimal process by which we can understand or we can verify which number is greater or which number is smaller for the fractions or the rational numbers. So one process is done. Another process, that will be 3 by 5 and 5 by 7. So from these two we have to multiply them diagonally. So the first one will be 21 and the second one will be 25. And we know that 25 is greater than 21. So we can tell 25 will represent this fraction. So it will be represented like this. So 3 by 5 will be smaller than 5 by 7 similarly. So this is the diagonal method. Okay. And for questions having mark 1, this method will be very much useful. This method is useful for the MCQs as well. If this question has been asked in the MCQ, so you just have to follow this method and take the correct option. The third method, which is very much popular and verified method, you have to, that is the LCM method. So 3 by 5 and 5 by 7. You have to make the both denominators as same. So 5 and 7, to make the denominators same, we have to multiply 7 with 5 and 5 with 7. So we are in the first case we have to multiply 7 with 5 and the next case we have to multiply 5 with 7. So for the both cases it will be 35, and the next thing, you have to multiply the same number in the numerators as well. So in the first case we have to multiply 5 with 5, it will be 25, and for the first case we have to multiply 7 with 3, so it will be 21. So now look at these two fractions, they both have 35 as their denominators and one having 21 as the numerator and the next one is having 25 as the numerator. So for these two, 25 by 35 is obviously the bigger one from the 21 by 35. So the 5 by 7 will be the greater one as compared to the 3 by 5. So all the three methods we have discussed and you guys can pick one. So let's go next. That is, they also followed the LCM method and this is the most followed one, but it takes time. You guys can choose the diagonal method as well, but for your school exams it will be better to choose the LCM one because the marks can be reduced or cut it down if you follow the diagonal method. So let's go next. That is, in this case they have described the diagonal method or the cross multiplying method, and yes, I have already done a sum, the previous sum, by using this method where you have to we have to multiply diagonally to get to know that which fraction or which rational number is bigger one. Okay, so this is just the explanation of the method. You guys can check it out, and that's the same. The next one, yes, they have verified this with the cross multiplication method or diagonal method. Yes, you can check this out, you can check this one. The next one, when both the given rational numbers are negative, compare them without their negative signs. That is, for rational numbers minus 3 by 7 and minus 8 by 15, compare 3 by 7 and 8 by 15, obviously. So for this case, if you want to solve the negative rational numbers, that which one is bigger and which one is smaller, but you are having both of them as the negative. So for this case, you have to multiply them diagonally, and the bigger number will be less. The more the number is big, the less the fraction will be. Okay. So we have to just flip the signs in the next case. So the next one, that is arrange the rational numbers in ascending order. So when we will be having more than two numbers, so then we don't have to apply the cross multiplication method, or the cross multiplication method won't be useful for these cases. So it will be minus 9 by 10, minus 7 by 8, and minus 3 by 4. For these cases, we have to take all the denominators and have to find the LCM. So 10, 8 and 4's LCM will be maybe 40. Yes, 40 is the LCM of all of them. To make the denominators as 40, what you have to multiply? So you have to multiply 4 in the first case, 5 in the second case, and 10 in the third case, or the third rational number. So in the first we have to multiply 4 as well. The second we have to multiply 5 as well, and for the third we have to multiply 10 as well. So it will be minus 36, minus 35 and minus 30. So this one is the smallest one. This one will be the smallest and this one will be the greatest. So it means that minus 9 by 10 is greater than minus 7 by 8, and minus 7 by 8 is greater than minus 3 by 4. This will be the final ascending order of this given sum. Okay. So next one, yes, they have done it like this, okay, and they have also used, oh no, they didn't use it. Okay, how do we find rational numbers between two rational numbers? So this one is a video, so let's watch the video. Yes, they have described this with an example, so let's watch this.
Here are the kind of problems that could be asked in your exams. Find 4 rational numbers between minus 4 by 7 and 1 by 7. Since the denominators are the same, we can easily
So here is the video. Now we will be going in the next slides or the next topic. So rational numbers between two given numbers. So here consider two rational numbers, that is minus 6 by 11 and minus 3 by 5. So LCM of the denominators will be 55, and their exact representation will be minus 33 by 25 and minus 30 by 55 and minus 33 by 55. So in between them there will be minus 31 by 55, minus 32 by 55, and yes, these two numbers will be in between them. So if we have to find or plot two rational numbers in between these two given rational numbers, we will have to just make sure that the denominators are the same, and then we have to find the other two numbers as well. Okay, so they have already found it. And the next thing is, maybe you guys are wondering that what if they asked us to find 4 or more rational numbers. So those are the special cases which we will be learning in the upcoming slides. So that will be, yes, mark the following pairs of rational numbers on the separate number lines: 3 by 4 and minus 1 by 4. Okay, so if you draw a rational number like this, 3 by 4 will lie between 1 and 2. So if this one is 1 and 0 and 1, so 3 by 4 will be placed here. So this is 3 by 4, and 1 by 4 will also lie here between 0 and minus 1. So 1 by 4 will be lying here, minus 1 by 4. And this has another, if you want to express this in another form, if you cut it down like 1, 2, 3 and 4, so minus 3 by 4 will be representing this point or this line. Okay, and minus 1 by 4 will be representing this line. Done. And this same the same will be going for another examples as well, for all the another examples. So let's see that solution. So yes, for the first one, 3 by 5 and 5 by 7, it has explanation of like this. You guys can practice this type of question in your own copy. Okay, maybe you guys have been being in trouble by seeing all this. Yes, this one is 3 by 5, this one is 5 by 7, and 5 by 7 is bigger than 3 by 5, so it will be represented like this. Okay, the next one, insert 3 rational numbers between this and this, this and this and this and this. So I am doing number 2 here. 1 and 3 you guys can try at your home. So for 5 by 7 and 7 by 9, for the same cases we have to make sure the denominators are same. So 7 and 9's LCM is 63. So to make 7 as 63, we have to multiply 9 in the denominator and in the numerator as well. So it will be 45 by 63, and it will be 49 by 63. So we will be having 3 numbers between 45 and 49. So those are 46 by 63, 47 by 63 and 48 by 63. So these 3 numbers are in between these 2 numbers. Okay, so this one is the final solution of this question, and the same you guys can try in your home with number 1 and number 3. Okay, so let's go next. And yes, they have already found it. I am skipping this. problems on rational number. The next one is addition of rational numbers. Yeah, the addition of rational numbers for the positive ones, the same goes as like the you guys have done in the fractions. So the LCM, we have to find the LCM first, then we have to divide the LCM with the denominators of the number, and the answer will be multiplied with the numerators, like they did it here. For this case, they have the same denominator for the two rational numbers. So the denominator will be the LCM, and the rest of them you have to run it like this. Okay. When denominators are unequal, yes, for that cases you have to find the LCM of both the denominators and have to find the sum as well. Okay. Okay, so subtraction when denominators are equal. Yes, for that cases when denominators are unequal, not equal, the same goes for the subtraction as well, just like the addition. Okay. So how do we add a rational number? This one as another video. You guys can check this video in the Fun Scholar app or in our in the Fun Scholar website. I am not playing it here because this one is a very basic thing. You guys already know, but let's do this with the worked examples. So the first one is minus 2 plus 3 by minus 2 by 5 plus 3 by 5 plus minus 1 by 5. If I am doing number 1, so we have to write it like minus 2 by 5 plus 3 by 5 minus 1 by 5. We know that minus and plus makes minus. So it will be having 5 as the denominator and minus 2 plus 3 minus 1. So in the upper side it will be minus 3 plus 3 by 5. So it will be having 0 by 5. And the answer will be 0 for the number 1. Number 2, you guys can try at your home. I will be doing number 6. So the first is okay. So the first is 12, 16 and 8. So for the first one, so look it carefully that in number 1 we had all the denominators as the same. But for number 6, we have different denominators. So we have to first find the LCM. So the LCM will be 3 2s are 6, 6 2s are 12, 12 2s are 24, 24 2s are 48. So 48 will be the denominator. And you have to divide 48 by 12, so it will be 4. So and multiply 4 with the numerator, it will be minus 44 plus 3 into 5, it will be 15, and the next will be minus 18. So the next thing is to minus 58 and 462 and plus 15 by 48. So it will be minus 47 by 48. This is the final answer. Okay. Yes, they have done it all like this. Yes, these are the test yourself questions. You guys can test it by yourself. The next is how do we multiply the rational numbers? So you guys watch the video. So here is the video. So how can we multiply two rational numbers? So let's verify this. So product of two rational numbers will be product of their numerators and product of their denominators as well. So the next thing is, let's do a multiplication. So we have to multiply 3 by 4 with 4 by 3. Just multiply the numerators, it will be 12, and products and multiply the denominators, it will also be 12. Now cancel these two out and we will be having 1 as the multiplication. And this is another example of multiplicative inverse or reciprocal. So for that case, we know that reciprocal means if the fraction, the flipped version of that fraction itself. So the reciprocal of 3 by 4 will be 4 by 3 and the reciprocal of 4 by 3 will be 3 by 4, and the multiplication of two reciprocal of the same number will be 1. Okay, this is another type of identity which we call as the inverse identity. The next is, how do we divide two rational numbers? I am not playing the video here. You guys can check the video in the Fun Scholar app. Okay, so let's watch. Let's do the division in the worked example. So for this case, you have to do the multiplication. I am doing a multiplication of this number 2. So this is the multiplication of 1 and 1 by 8 into 10 and 2 by 3. So the multiplication will be 9 by 8 into 32 by 3. Okay, so now we have to multiply both of them to find the answer, but before multiplying we have to check if we can cancel out the fractions. Like, it can be cancelled out like this. 8 and 32 can be cancelled out. It will be 4 and 1 here, and 3 and 9 also can be cancelled out. It will be 3 and 1. So 12 will be the answer. Okay. The next one, let's do it for number 6. So it is 29 by 14 and minus 7. Okay, so we have to cut it down like 1 and 2. So it will be minus 29 by 2 and the answer will be 14 and 1 by 2. Okay, so done for this, and the rest of all you guys can try at your home. Okay, let's go next, and yes, they have given the solution as well. Now this is like a mixed bag of questions. So let's do number 3. So for number 3 it will be 41 by 12 plus 5 by 3 and division of 41 by 12 minus 5 by 3. Okay, so the first case we have 12 as the LCM. So it will be 41 plus 20. So we will be having 61 by 12 division by 41 minus 20. So it will be 21 by 12. So it will be 61 by 12 into 12 by 21. 12 and 12 will get cancelled out and the final answer will be 61 by 21. Okay. Yes, 61 by 12. Oh sorry, maybe I have mistakenly write 12 as the 21, so it will be 12. Yes, they have done it right here. Okay, so that's it. That's the video, guys. That's the complete of rational number for class 7. I hope you guys have enjoyed the video. If you have any questions, comment it down below and we'll be seeing in the next class. Okay, bye bye.